Too late now. We're going. So, I want to talk to you now about greatest common factor. I want to give you an actual person definition, not a textbook definition. An actual person definition for greatest common factor is the biggest number that two numbers have in common as a factor. So here's the hard part about the actual person definition. It makes no sense until you see it work. So you're going to have to kind of hang with me for a minute. Let me explain what the actual person definition is. Write down the actual person definition, then I'll show you how to use it, and you'll go, oh, okay. I got that. That makes sense. Good?
Yeah.
The greatest common factor is the biggest number that you can divide a numerator and denominator both by. To reduce a fraction. There we go. Sorry for the jiggliness on YouTube. So, we use greatest common factor when we are reducing or simplifying. Now, here's the straight up answer as to why we care. Why we reduce or simplify a fraction? You know good and well that in everything we do in 5th grade, we're like, here, solve this math problem. Well, that's the first step. Now that you know how to do that, solve a math problem where you have 3 different steps, right? Take the first answer, use it on the second step. Take the second answer, use it on the third step. That's the last answer to the question, right? When you get to that second step, it is going to be very helpful to have that fraction cut into the fewest pieces it possibly can be. Otherwise, you're just going to be dealing with a whole lot of bigger numbers. And the fun part about fractions is it's almost all simple multiplication or division. It's like 3rd grade, 2nd grade, memorize your facts kind of multiplication and division. Like it's that kind of multiplication and division. So if you keep your fractions in simplest terms as much as possible, the math is way easier to deal with. Now, I'll take a fraction. Let's go. 6/24. This is not a simplified fraction, correct? Yes, ma'am. Sure. Yeah, I would definitely write down examples for this. I'm only going to do one example, so you're not going to be stuck writing down 4 million things. I'll show it to you once, and you'll be like, oh, yeah, okay, totally. We know factors are the things that you can multiply together to get a number, right? When I start making these lists, I'm going to show you 2 ways. Mrs. Grace showed me a way better way last hour. The way I was always taught was, what makes up 6? What things can I multiply together? I can start with 1 and 6. Then I know 2 and 3 can also be multiplied together. You've done this before, right? This is where everybody's flashback to and they're like, oh, yeah, totally, I get that. You want to see what Miss Graves showed me last hour that's way easier than making a list like that? Miss Graves said do a T-chart. What makes up 6? 1 times 6, 2 times 3. I like this way better. My brain thinks about this and sees multiplication tables instead. If your brain does not do that, feel free to make a list. It does not matter at all. Okay, so if we're looking for factors that these 2 numbers have in common, so I have to see the factors for 24 as well, right? One times 24 is the easiest place to start, right? Is there anything times 2 that'll get you 24? $12. Anything times 3 to get you 24?
Yeah.
What is it? Anything times 4 gets you 24?
Yes. 6.
What on these two lists, what's the biggest number that is on both lists?
The biggest number on this list?
The biggest number that's on both lists.
24 and
24 and 12 are not on this list.
12. Oh. 6.
What this means, because multiplication and division are related, right? Inverse operation. If I can multiply to get a 6, that means I can divide this number by 6. Six divided by 6 is what? 24 divided by 6 is what?
4.
6/24 is the exact same thing as 1/4. Now remember, when we're changing this fraction and reducing it, we're not magic wand poof, right? This is not fairy dust, fairy godmother, glitter in the air, poof, we made it something different, correct? We are messing with the pieces. If you diagram 6/24, it's going to look exactly like 1/4, but cut into a lot more pieces, correct?
Mm-hmm.
As a matter of fact, it's going to be cut into 6 times as many pieces. That means this 4, for every one piece, is going to be 6. So if I have 4 groups of 6, I have 24. How many of those pieces are going to be shaded in? If 6 of these were shaded in, one of these is shaded in. That means if I take this 1 and I shade in, or I take that 1 and cut it into 6 equal pieces, I'm going to have 6. So everybody in 5th grade freaks out about fractions and reducing and simplifying and all that. We are not poof with sparkly fairy dust with these fractions. We're just messing around with them to see if we can get it, where it needs to be. We're not making any changes other than very, very simple dividing or multiplying. Like almost always even 1-digit multiplying or dividing. Decent? Good?